I want to say welcome to Regina Hagen. She was in the... When I met you first, you were in something that was called INESAP. And I can never know what this acronym is for. Can you tell me?
It's the International Network of Engineers and Scientists Against Proliferation. It's an international group of scientists, physicists, many, who work on nuclear abolition and against missile defenses and space weaponization. And I am not the great expert on space issues. There are people who know much more than I do. But they are usually not the speakers who come to such events, and they often don't come to the same conclusions as we do. They are usually not peace activists. They are peace researchers. They work in think tanks, who are usually or often either funded by governments or by big foundations that are not as radical as I tend to be. I want to mention that there is one other European who works also watches very closely things going on, and I sometimes in this talk use material from him. His name is Frank Sleiper, and he works with the campaign against weapons exports and with the Transnational Institute in Holland. So I want to acknowledge the information he provides. I want to guide you through a few questions. One is, how is space used at all? That might be sort of a mystery to some of you, and I want to briefly cover this so that you might better understand the military implications later during my talk. I want to also briefly explain how the European Union became militarized. I think everyone here is in an age when you remember that the European Union was not always a European political union, but an economic union, dealing exclusively with economic issues. So there was a change from that to a union that also includes military policies. And then I want to present a few relevant space programs that have military implications, European space programs, and one of them is Galileo, on which I will say a little more because Agneta requested that I do so. So very briefly, to give you a better impression of what we talk about, what is space? There is no precise definition. Amazingly enough, there is no precise legal definition of what space is, but generally it is understood to be everything beyond 100 kilometers above Earth. So when you take the atmosphere around the Earth and go 100 kilometer high, and everything above that is space. And there is special law on space. For example, when you want to fly over a country, when I fly from Germany to China, I usually fly over, like Poland and Russia, and the planes need a permit to fly across those countries. This is not necessary in space, because space, through the Outer Space Treaty of 1967, is designated as a heritage of mankind. It belongs to everyone and to nobody. And no one can claim the moon is mine or so. You can claim your own satellite in a specific spot in space, but you cannot claim space. And space has specific physical conditions. Like when you go high up, not yet with 100 kilometers, but higher and higher and higher, there is no atmosphere in space. That means there is no longer friction when you get really high up, which means that an object flying through space is not slowed down through an atmosphere as it happens here on Earth, when things become slower when traveling through space, because there is the friction of the air which slows them down. Once an object is in space, the speed with which it travels, the trajectory, the direction, and other characteristics of the flight of this object are determined by the rocket that brings it up into space, unless it has its own thrusters, its own system to either lift it or to move it on an orbit. That is an important characteristic, especially when it comes to nuclear warheads that do not circle around Earth, but they are sent out into space, and then the warhead is released by the missile and travels with the laws of physics until it comes down on the other side, or if it's short range, in another place. There is no gravity. That means when you go really far outside, like the geostationary orbit, the speed of the satellite, how to say it in another way around. When you are in a rather low orbit of Earth, like the International Space Station, for example, you need to lift the object occasionally because there is still some gravity pulling it down to Earth. Like when you drop something, it falls down to Earth. It's similar with objects that are in very low space because there is still so-called microgravity. This is no longer true when you go very far outside. And eventually, actually, there might be gravity from other bodies in the far universe, not the Earth anymore. So that is the basic characteristics of space, which are very different from what we know here from Earth. And these characteristics are true for all objects in space, be they rocket stages that were no longer needed but remain in space as space junk, it is called, or debris no longer needed but still in space, or warheads that are released in space. That would be the case for nuclear weapons. It's true for satellites, but it's also true for everything else that ends up in space, like a screwdriver an astronaut might have slipped out of hand. It circles Earth and has, keeps the orbit and the speed and everything it had when it was released. So space flight has always been a dream of humankind, to go out into space, and but it really started by the Germans. Some of you, or probably most of you, know that the origin of space flight as we know it today is actually military. The first rocket ever that went into space, that reached the 100-kilometer height above Earth, was the V2 rocket built by Wernher von Braun and his crew in Peenemünde and in Mittelbau-Dora, where they used Nazi camp labor to produce the missile. And the first test ever was done in October 1946. So we will in half year have the 70th anniversary of the first ever successful launch of a rocket in space. That was the first V2 test that was successful. And about a year later, 2 years later, the Nazis were already far enough advanced to actually use thousands of missiles and send them to London and Antwerp and Liège and actually kill people. Although, of course, then there were no nuclear warheads on board of these rockets, and they were rather primitive and not precise where they landed. So let me figure out this computer. There, one of the officers, the military officers who worked with Wernher von Braun in the Peenemünde project, after this very first successful test of a rocket, or as it then turned out, missile, the distinction I make is rocket for peaceful uses and missile for military. I find that helpful to distinguish with the vocabulary. So he then commented as follows. He said that it was the start of a new era in transportation, that of space travel. And then he continued to say that it's a quote, our most urgent task can only be the rapid perfecting of the rocket as a weapon. So you see, the origin is military. Immediately after the war, the United States and the Soviet Union, and by the way, many other countries, started to work on rocket and missile programs. And the race into space has, since 1945, been driven by the Cold War. So it was mostly driven by the military aspects, and even the peaceful, the civilian program, like the Apollo program of the United States that brought people on the moon, was driven through that military competition between the two powers. Both the Soviet Union and America brought engineers, technicians, scientists from one of von Braun's team to their own countries. And those German engineers, scientists, technicians helped to build the missiles and the rockets of the Soviet Union and Russia and America. And at the same time, as you are aware, both countries worked on nuclear weapons. And the rockets, the missiles they built, increasingly had wider ranges. That means they could fly more kilometers until eventually they became intercontinental, and the warheads, the nuclear warheads, became smaller until they were small enough to fit on a missile. And that became this development. Things really came together in 1957 when the Soviet Union launched the first ever satellite, the Sputnik satellite, in October 1957. That is 1957, which was 15 years after the first V2 test. Because when you can launch a missile or a rocket that goes far enough into space to launch a satellite, you can also launch a nuclear warhead and deploy it on the other side of the world. So that was the beginning of the so-called intercontinental ballistic missiles, and was a great shock to the United States, because that now their territory, the United States territory, could actually be threatened with nuclear wars from the Soviet Union. Today, life is almost unthinkable without space technology. There are many civilian uses, whether you are aware or not, like TV programs that come through satellite, the satellite TV. When you use an ATM, a bank machine, to withdraw money, it uses satellite technology. Banks use it for financial transactions. The whole financial sector could be sped up terribly, which is part of the reason for the financial crash. Aviation, or the airplanes, use space satellites, in particular GPS, but not only. The ships on the high sea use satellites. Precision agriculture in countries where you have large fields. The tractors, the machinery that is used to do agriculture actually uses GPS to do the precision fertilizing or watering or whatever. Weather forecast is done by satellites, so there is a lot of civilian uses. There are at least as many military uses, and I will tell you a few. And I could not understand what Bart said in his talk, but I think that he might have talked about many of the programs that use the technology. One of them is, for example, infrared. Infrared is a technology where you can see heat. It sees the difference between cold and warm. So with an infrared satellite, for example, you can recognize that a missile is launched because it has a hot exhaust fume from firing the thrusters. It's very hot. But you could also see the heat that is dissipated, by example, by the engine from a tank. That was very relevant in the Kosovo War, when the United States, or when the NATO coalition was cheated by Milosevic by wood structures that looked like tanks and putting inside a heater, because then it had a different infrared signature than the cooler environment, and the infrared satellites mistook that for active tanks, although it was only attrape, decoys. Yeah? Attrape, okay. Or you could see the heat difference when a submarine submerges below sea level. Then, of course, there are communication satellites, and it's not only the satellite telephone that is used in many cases, but also to allow the military to communicate. It is absolutely required for command and control. For example, when the drones are used in the Afghanistan war, a soldier or a specially trained person who might now not even be a soldier anymore, but a civilian, sits in front of a computer like he did a computer game with a joystick. And he is fed information from the drone that circles in Afghanistan through satellites to his screen. That's communication satellites that do it. And then he gives the command to shoot a missile or to release a bomb, command and control. That's again, the command is sent through a satellite to the drone, which then fires the bomb without any person on the ground being involved, only the soldier in the United States, who does his shift and at 6 walks away from his workplace, goes home, has supper with his child and brings her to bed. That's today's war reality. Unthinkable without these satellites. Weather satellites, the military highly depends on information about weather. Just think of tanks doing an attack, and then there is suddenly a very strong rain, and the tanks get stuck in the mud. You want to know what the weather will be like. Some mission is dependent on the environmental conditions. They don't function so well when there is fog or rain. So weather satellites are crucial. Navigation satellites, usually known as GPS, but now Europe is building its own navigation satellite system, the Galileo system, which sends precise time data, precise position data, and is used for navigation. Many of you know it from cars. The ships nowadays use it. There are hardly any light towers anywhere anymore because the ships use the GPS data. And of course, it's used by the military. When you have the so-called precision bombing, the munition, the bombs that are dropped, or the missiles that are launched from an airplane or from a drone, is guided through satellites to the exact target. And then there are geodetic, I hope the pronunciation is correct. Geodätisch is the German word. Don't know whether that resonates with you. Satellites who give information, which give information about the terrain, about valleys and mountains and high objects. Topographic? Yeah, similar. And those are very important for when you use cruise missiles, who don't fly like a ballistic missile in a ballistic trajectory, but they follow the landscape to remain below radar visibility. So you need to know the terrain data, where there are mountains and valleys and even stretches. So those also all come from satellites. That is all, and there is much more than this, but that gives you just an impression how much different technologies can be used in space and are used for military purposes. Now, the relevance of space to the military is striking. I have 4 quotes for you from US military. The quotes are from Wednesday last week, when there was a Senate hearing in the United States, in the United States Senate. And it's all leading military people who spoke there. And I chose the quotes. So Air Force General William Shelton, the head of the Air Force Space Command, said, "Our assured access to space and cyberspace is foundational to today's military operations and to our ability to project power whenever and wherever needed across the planet." That means global warfare needs space technology. Army Lieutenant General Richard Formica, who is the head of the Army Space and Missile Defense Command, claims that his service is the biggest user of space-based capabilities. That is, the military uses most space capabilities, and those are critical to land operations. If the Army wants to shoot, move, or communicate, it needs space, he said. Robert Winocour, Director of Oceanography, Space and Maritime Domain Awareness, look at these names, of the Navy, the Department of the US military, said, "Space capabilities enable effective command and control responsiveness and agility necessary for a globally engaged, superior naval force consistent with emphasis on forward operations." That means we call it out of area in the NATO context, outside your own country, and for joint operations. That is operations where the Navy, the Air Force, the Army work together, and the Marine Corps. And the last quote, again from Formica, "Virtually every Army operation relies on space capabilities to enhance the effectiveness of our force. There is no going back." The space budget, alone the space budget of Pentagon in the budget request of President Obama for the year 2013 is 9.7 billion, and that is only the dedicated military budget. But a lot of the militarily used technology is not dedicated military satellites and systems, but civilian ones used for military purposes. Great Britain, for example, buys technology or even devices on commercial satellites for their use exclusively. And other data is bought from generally civilian devices and satellites. And the data is sold maybe to an insurance company, maybe to the farmer who does the agriculture, but also maybe to the military. So this runs under the name of dual use. Now, to come to the European Union, Who are the players in the European Union when it comes to space? You have, of course, the European Space Agency, that is the space agency in Europe, the agency in Europe for space issues, the equivalent to NASA.
It's ESA.
It's ESA, European Space Agency, ESA, or ESA, depending on how you pronounce it, which is under control of the European Union and was founded with a constitution, with bylaws that restrict all its activities exclusively to peaceful uses, peaceful purposes. Another player when it comes to space is the European Commission. Now that is nowadays also responsible for all military aspects of the European Union. The European Council, the European Defence Agency, which was founded in 2004. You can see how far this European Economic Union has proceeded to include the military aspects. Then, of course, the national governments and parliaments. The parliaments, for example, agree to the budget for the European Space Agency, but also for the European Union and for the space programs of the European Commission. And then, of course, the national ministries of defense who decide on use of space data and technology. The European space policies, the military aspects, date back to 1993, when in the Maastricht Treaty of European Union, the so-called Common Foreign and Security Policy was defined, CFSP, all these acronyms. Then there are the so-called Petersberg tasks, also from 1993, that were at that time defined by the Western European Union, which was the military arm of the European Union, but not all countries of the European Union were also members to the Western European Union. These two were merged. This is how the military aspect officially came into the European Union. And then the European Security and Defence Policy, ESDP, was defined in 2000. So there is a constant development of militarizing the European Union. Space militarization pretty much dates back to these policies, but in particular to a report that was written by the so-called Three Wise Men, Carl Bildt from Sweden, Jean-Pierre Levade from France, and Lothar Späth, who used to be the head of the federal state of Baden-Württemberg and later of Jena Optics in Jena. They were tasked with writing a report for the Director General of the European Space Agency. They were labeled Three Wise Men. And the report was called Towards a Space Agency for the European Union. And there they referred to the so-called Petersberg tasks. The Petersberg tasks are pretty much reflected in the new constitution of the European Union. And this is a quote, unfortunately, from the draft, but I don't think it changed much in the actual constitution. I didn't have the actual constitution on my computer. The draft said that the European Union may use civilian and military means, including joint disarmament operations, humanitarian and rescue tasks, military advice and assistance tasks, conflict prevention and peacekeeping tasks, tasks of combat forces in crisis management, that would be Libya, for example, including peacemaking, I call that war fighting, and post-conflict stabilization. Now, does this really mean war fighting? Because the European Space Agency is still under its constitution that says peaceful purposes only. So we really need to look at words: peaceful, conflict resolution, humanitarian intervention. And I will show you brief in a second. All this is now defined as non-aggressive. So we move from peaceful to non-aggressive. And Libya, for example, was non-aggressive because it was the so-called responsibility to protect. It was humanitarian relief.
But they died.
So I searched the internet for more information on military uses of space in European Union, and I came across this presentation. It is publicly available on the internet. I got it yesterday. I found it yesterday, which was given by Erwin Hamel, ESA, European Space Agency Office for Security and Partnership Development, and talks about so-called GIANUS, which stands for Global Integrated Architecture for Innovative Utilization of Space for Security. Security is another one of the words I should have added on the previous list. And I want you, GIANUS, I want you to look here. You can't see it very well, but it is a Janus head. Janus is the Greek double-headed god. And the working group where I worked at the Darmstadt University of Technology for 8 years until a few years ago calls itself Janus, where the E stands for interdisciplinary. Janus usually is spelled with a J, because they talk about the civil-military ambivalence of technologies, and that's what we actually have here. And I was struck to see this Janus head here as a logo on this slide. So why do I show you this slide? I continue with his presentation. This is not mine. I didn't change anything. The only thing I changed was that I marked certain things in yellow so that it's easier to see. I didn't even mark them in this version. So, the policy drivers for defense and security in the European Union come from the European Union's security strategy of 2003, a secure Europe in a better world. And it says, this is paragraph 1b, space systems are an essential part of the development of a European security and defense policy. It says that the European space policy is based on the peaceful, hear the words, hear how they do Orwell speak, the peaceful exploitation of outer space, and seeks to meet Europe's security and defense need as regards space. Synergies between civilian and military actors. Sharing and pooling the resources of European civilian and military space programs. And a bold print here comes from his presentation, not from mine. He mentions European Space Agency may only perform its space programs for peaceful purposes. And then he says, within this legal number 3 and political framework, Europe has some programs, and he mentions specifically Galileo, GMES, that is the Global Monitoring for Environment and Security, and SSA, which stands for Space Situational Awareness, knowing what is where in space. I'm looking for a specific word. Sorry. I should have downloaded. Oh yeah, here. I went over it. But go back to point 1 here. European Space Agency can develop security-related programs as long as they remain non-aggressive. Here you have the word again. You can do everything militarily as long as you do not violate the Charter of the United Nations and on your own attack another country. Everything else is permitted under this understanding of peaceful. And that is the definition of peaceful tasks from Petersberg. No? So I'll briefly talk a little more about some of the programs and the elements of the European space policy, military space policy, and one is GMES. I already said this stands for Global Monitoring for Environment and Security. And again, look at words. When this program was designed, security was meant to mean human security. For example, security when there are huge floods to help people, or when there is a volcano eruption or an earthquake to help people. That originally was the meaning of security in the GMES program. And now GMES includes combating all threats that might affect our population, institutions, environment, economic infrastructure, socio-economic interests, and strategic interests. And a narrow coverage is now assumed by European Space Agency. Delivery of products to military and paramilitary users by the European Space Agency. And information to support the Common Foreign and Security Policy. That's the one defined in 1993. And the European Security and Defense Policy defined in the year 2000. Excuse me. GMES, to have the GMES program was decided by the European Council back in 2001. It was set up by the European Commission in 2005, and full operationality is expected in the year 2014 or 15. GMES does not mean that additional satellites are necessarily launched into space by the European Union. Rather, it networks existing satellites. It could also be new ones. But more, it's about collecting data from satellites that are there in the European Union, collect it through ground stations, coordinate the collection of the data, analyze and process it, and then give it to end users for environmental security, for human security, but also for military purposes. This is an extract from questions brought forward by the Green fraction of the European Parliament to the Commission that ask about the military use of GMES. And the bold here comes from me. I used the bold to mark it. They say that it is said that GMES is used to camouflage the use of these satellites as spies for military purposes. And they mention another very important aspect that hasn't really been talked about a lot yet, at least not to my understanding. I'm not too sure whether Bart mentioned it. It's the profit, it's the space industry. This question to the Commission mentions that it is a very profitable business for Europe's military industry, which receives the lion's share of funding for research projects, civilian and military ones, which often compromise a military and security dimension. So I'm not making this up. What does GMES do precisely? It monitors the land. That means it uses satellites, radar satellites, infrared satellites, optical satellites, to look down at Earth and see what's going on. Which can mean that it observes, for example, the degradation of forests, but it can also be used to observe other things that are of military usefulness. It monitors the maritime environment, which means the high seas. It monitors the atmosphere, which can, for example, be useful when there is an eruption of a volcano and you want to see the dust cloud drifting. You remember this volcano, which names I can never pronounce in Iceland not too long ago. Emergency management, for example, after an earthquake. Climate change, GMES is very active there, but also security. Another element of European space militarization is the European Union Satellite Center in Torrejón, which is near Madrid in Spain, which was opened in 2002 and then was the satellite center of this military arm of Europe, the Western European Union, but now has been integrated fully into the European Union. It was the first dedicated, exclusively military space facility in Europe. And its task is to exploit and produce information is obtained from satellites and make that available to the military. That's its task. It is financed by the member states, but it also sells services, namely processed data, to member states or to other organizations, for example, the North Atlantic Treaty Organization, NATO. Apart from European satellites, it also uses data from national satellites, for example, from the optical Helios 2 satellite from France. And that was for the data from that processed through this satellite center in Torrejón was, for example, used for is used for anti-piracy missions, for example, around Somalia, and for military operations in Congo and Chad. An important aspect of the combination of global monitoring for Earth and environment, this Torrejón Space Center and Galileo, is that in combination, these give Europe the capability to run or to use fully autonomous aerial vehicles, UAVs, and the other name is drones, and guided weapons. Now, Galileo. Galileo was designed, with Galileo, you already mentioned, there is a facility here in Sweden in mid-December last year, just 3 months ago, about 200 kilometers north of the Arctic Circle, a new facility opened specifically for Galileo at the S-Range Space Center, namely one of 2 ground stations for Galileo. So Galileo has 2 ground stations, one here close to Kiruna, and the other is in Kourou, which is French Guiana, and which is the European spaceport, where European space missions are launched. There is another 2 ground stations, but for operation, and they are located in Germany and in Italy. Galileo will eventually consist of about 26 to 30 satellites in 23,222 kilometer high. That means in a medium height orbit. To give you an idea what that means that each satellite circles, because when a satellite is in a very low orbit, like the International Space Station is, in a rather low orbit, it sort of circles Earth very quickly. Earth turns once in 24 hours, right? These satellites go much faster. So the space station circles Earth once every 90 minutes, once every 1.5 hours. When you are in a geostationary orbit, the speed is so that the satellite moves at the same speed as the Earth below turns. So it's always above the same spot of Earth. In a medium orbit, the satellite is slow, but not so slow that it stands still. So the Galileo satellites have a speed that bring them around Earth 17 times in 10 days, just to give you a rough idea. Currently, there are 4 satellites in space that are still used to validate the system. In 2002, the 26 or 30 satellites are expected to be available, although, you never know. The first idea was that it should be fully operational in 2010, 2 years ago. It never happened. Galileo is run jointly by the European Space Agency, ESA, and the European Commission, and they agreed on doing that in 2003. To find the funding was extremely difficult because it's expensive. The current budget foresees 1 million per year for Galileo. Galileo will provide 5 services, and I will tell a little bit about what that means. I listed the names of the services here, and I will give you a few more details. The open service has its name because it is open for use by everyone. For example, you can have, rather than a GPS receiver, you can have a Galileo receiver in your car, or when you go hiking in the mountain, or the taxi and lorry drivers, or whoever. So car navigation is an important application, but again, they talk about precision farming. The other one is the so-called search and rescue service. And I'll tell you what I found in an explanation from the Galileo Consortium on the website, which is a European Union website. They say this service is unique to Galileo. In times of emergency, for example, a sailor lost at sea, not only can he send his distress signal, but with Galileo he will receive a confirmation message that he has been located and that help is on its way. Good thing, right? Then there is the safety of life service. It provides information for what is called the life critical applications or the safety of life services, for example in navigation, so that the planes come down to the airport exactly on the right angle and the right distance and everything. So GPS can be very useful there. Then there is the commercial service, and all these use different signals. That's why they can be separated from each other. The commercial service is still very open whether it will actually ever be used, because it must be paid for to use it. But that is what the European Union hopes will produce huge profits, billions and billions and billions of profit, and we will see whether this materializes or whether it was just a dream. But really, for our purpose of this seminar here, application of Galileo is the last one, the public regulated service, which is not a dangerous name. PRS is the acronym. And this website I already mentioned says that it ensures that key services dependent on satellite navigation, such as police and ambulance service, first help, continue to function in moments of crisis, terrorist threat, or natural disaster. That means when the other service, the open service, no longer functions, this public regulated service is guaranteed to function in such cases. PRS is limited to police, firefighting, customs, rescue forces, and military of European institutions, European Union members, and other participating states. There are quite a few states that now buy into the system, international organizations. When Galileo was decided on in the national parliaments, I'm almost done. When Galileo was decided on in the national parliaments, and they needed to decide because of the additional budget that is required, it was usually, when they agreed to it, it was usually promised that Galileo would be strictly civilian. And they still have the old mantra of it's under civilian control, which is true, but it is not the same as strictly from a peaceful non-military uses. And here we have a German press agency release of 2008, where they say that the European Parliament approves to the military use of Galileo satellites. That is 4 years ago. And the interesting thing is that the bill was proposed by the German conservative politician Karl von Wogau. And he chairs the European Parliament Security and Defense Subcommittee. So the European Parliament officially, formally agreed that Galileo be used militarily. And then again, just half a year ago, the European Parliament approved the Commission's proposal on the public regulated service, that is the militarily usable one, rules, the rules brought forward by the Commission for Galileo. This special service will protect the functioning of management of critical transport and emergency services, police work and border control. Border control means Fortress Europe, keep away those bloody refugees from Africa. We don't want them. We want to see them in the Mediterranean and around the Canary Islands. This is what is meant here. I mean, we must really look at how they use the vocabulary. That is border control, right? As well as peace missions. Libya, think of Libya, peace mission, via its highly robust encrypted signal. So the ground station built here in Sweden is one of two that are needed, that all this becomes possible with the 26 or 30 Galileo satellites. It really plays a crucial role in this whole system. And with that,
can you just explain what is a ground station? It sounds so easy.
A ground station. I should have brought a picture. A ground station is a satellite dish that stands in the middle of an open space in the forests. It's a huge satellite dish, which is used to collect the data from the satellites that pass across it. And because, as I explained, the Galileo satellites sort of pass over a certain point on Earth very slowly because they are so high up, there is a long time when one satellite sends data to the satellite dish, and from this satellite dish it is then relayed to those stations in Germany and Italy where the data is processed so that it can then actually be used. But without these two stations, the satellites are useless. They cannot send their signals. So these two ground stations are crucial for the functioning of the whole Galileo system. And with that, I'm done. Thank you.
Thank you very much.